Today I'm going to discuss with you clipping circuits. My dear friends, you know very well that clipping circuits are also called limiters. This is another name of the clipping circuit. Amplitude selectors or the slicers. And the application of what is the clipping circuit. Clipping circuit is used to remove the part of the signal, that is above or below some defined reference level. We know very well that the example of clipper in the half-wave rectifier, their circuit basically cut off everything at the reference level of 0, okay, and only the positive going or the negative going portion of the input waveform. So let we discuss first of all the clipping circuit. We discuss it, how the clipping circuit is. This very simple diagram for the clipping circuit: a resistor and a diode. This is a resistor, okay, and then we are having a diode. Then across the diode we are getting the output. Input voltage is applied between the two ends. And no battery is attached in this case. So we will find if the sinusoidal wave, this type of wave, this is a sinusoidal wave. If this type of wave is given between the 2 points, then what will be then the output? Okay, so let me start with. The diode is our ideal diode. Ideal diode in a sense, if the voltage is just above the 0 level, then the diode becomes forward biased. If this is a P of the diode, okay, this is a P section of the diode, and if at the P section the voltage is just above the reference level, the diode becomes forward biased. So when this half of the input comes between the 2 points, then the diode becomes forward biased. When the diode is forward biased, its resistance, because it is ideal, so that's why the resistance of the diode becomes 0. For the ideal diode, no resistance, no forward resistance. That means short circuit between this and this end. Short circuit means because there is no resistance between the 2 points. That means the voltage will be 0 across the 2 points, because voltage is current into resistor by Ohm's law. V equals to I into R. Because when the circuit is shorted, that means no resistance, the voltage across the 2 ends becomes 0. Okay, so that's why we are not having any output. So there is no output, because here the output between 2 points is 0. Now things the other way. When the negative half comes, what happen when the negative half comes? Okay, when the negative half comes, this negative half, now then here will be negative with respect to let this the ground level. Okay, so here is negative with respect to this point. When this is negative, mean the voltage at P is negative with respect to N. when voltage as P is negative with respect to N, so this becomes, the diode becomes reverse biased. And the diode is ideal. Reverse biasing of the ideal diode mean infinite resistance. Mean that this diode will act like an open switch. So this is a switch. This is a switch. Now it is open. Open means no current can flow. So it means whatever the voltage at here, the same voltage will remain over this line with respect to this. That means this negative half will appear across this point because no current can flow through this line. So whatever the voltage is at here, it will appear at this end. So we are getting, we are getting an output like this. Okay, next again, when the positive cycle comes, it becomes forward biased, short circuit. Short circuit means no voltage. Again, there is no voltage. Again, reverse biasing, open circuit, voltage at here appears at here. So this is how we are getting, the clipping of the waveform. Now let me discuss another case. Okay, now here again the p-n junction diode. Now battery is attached, the positive end and the negative end. Now because this battery, the diode is positive at here and negative at here, and to the end the positive is attached, means this diode is already reverse biased already with this voltage, and the diode is ideal. When the diode is reverse biased with VB, when the positive comes and this positive is coming and the voltage this is coming, but this voltage is less than VB, less than this. So it cannot make the diode forward biased because already VB making it reverse biased and this voltage is less. Okay, but simultaneously this voltage is increasing. A stage comes when it just becomes equals to what VB. Then this voltage tries to make it forward biased. This voltage tries to make it reverse biased. So when just this voltage goes up from this level, just goes up from this point, then the forward biasing voltage, increases as compared to VB. So this diode becomes forward biased. This diode is forward biased, ideal diode. No voltage across the ideal diode. So what will be the voltage at the two end? The same as that of the VB. So VB appears at here. So it's going up, but no change. Voltage remain across the output equals to VB. So this is the case. The output remain equals to VB. Like this. No change. Now again, when the signal is going down, again, this voltage is going to weak, but this voltage VB, it make it again reverse biased. Reverse biased mean open circuit. When this is open circuit, so whatever the voltage at here appears at here. So the same voltage appears at here. So when the negative half comes, again the negative cycle also make it reverse bias. This diode is already reverse bias, and this negative at this end, it supports this VB. Mean it also makes the diode reverse biased. So mean open circuit. So voltage at here appears at here. So that's why this voltage goes like this in the output circuit. Again, Again, when the voltage, the next cycle comes like this, and when it goes high from this point, so it makes the diode forward biased, and ideal diode short circuit, and voltage between the two end becomes equals to Vp. So there's again the Vp. So this process repeats. So we are getting the clipping, but the reference level becomes this, sorry. Now from this level, it is clipped, this part and this part. Now coming to this figure, here the situation is different. This is the diode and Vp. Vp is making it forward biased. Already Vp making it forward biased. Forward biased means short circuit. And this cycle comes. And this is, going to, because the upper is N. This is going to N. Okay. This is going to N. But this voltage is less than Vp. So it remains forward biased. So, the voltage, output voltage will be like this, Vp. And the voltage goes high from this level. So now this is applied to N. Mean positive is applied to N. And this voltage is going to be greater than Vp. So it makes it reverse biased. When it makes it reverse biased, it acts like the open circuit. If this is open circuit, so whatever the voltage is going to change here, the same voltage appears at this end, because current cannot flow now. So same voltage appears at here. So this voltage is appearing. So when this voltage goes down from this point, that means reverse biasing is, the strength of the reverse biasing is decreasing. When it goes down, then Vb, make it again forward biased. So this becomes, it is ideal diode, short circuit, and voltage again becomes equals to Vb. The upper end means this N, when it is going down, the upper end becomes, the forward biased. Forward biased means ideal diode means short circuit, and voltage between the two remains Vb. So it remains Vb so long is going down, 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 and again up to here it is forward biased. But when it just crosses, when you're just crossing this end, okay, so what happens? This positive voltage make it reverse biased, open circuit, and whatever the voltage is going to change here, that appears across the output. And when it goes down, okay, again this becomes forward biased, right? Going down, it becomes forward biased, ideal diode. So that means at the output the voltage remains equals to Vp. So this is how it's going. We get the output of this shape. Now we coming to this figure. Now here, this is the diode positive, negative, negative, positive. Okay, the N with N. That means already this diode is already forward biased. Forward biased means it acts as a short circuit. So voltage across the output will be negative voltage, because negative polarity is here. So this voltage will be negative like this. And positive half is coming. It again forwards the forward biasing. It favors the forward bias. So that's why the diode is forward biased and no change. The output remain equals to Vp minus Vp. So when voltage goes going down, but it just crosses this negative voltage. Negative voltage at here. This negative voltage crosses VB. It becomes more than VB, greater than VB, negative voltage. Then it becomes reverse biased, open circuit. When this is open circuit, whatever this portion, it will appear at the output. Same. Again, when the signal voltage becomes weaker, then when the signal is going to weak, like less negative, then this VB makes the diode forward biased. When make it forward biased, short circuit, again across the output, the voltage remain equals to VB. So this process repeats and we'll get an output of this shape. मैं इस फिगर को हिंदी में एक्सप्लेन कर रहा हूँ कि ये जो बैटरी है ना नेगेटिव पॉजिटिव, इसने इस डायोड को रिवर्स बायस कर रखा है. रिवर्स बायस का मतलब तो ओपन सर्किट कर रखा है. तो वोल्टेज जो यहाँ पे होगी वो यहाँ अपीयर हो जाएगी, राइट. जब ये सिग्नल आएगा, ये पॉजिटिव सिग्नल है ना, तो पॉजिटिव सिग्नल क्योंकि डायोड का ये नेगेटिव है, ये वोल्टेज भी इसको रिवर्स बायस ही करेगी डायोड को, क्योंकि ये पॉजिटिव वोल्टेज है और ऊपर एन है डायोड का, तो ये भी उसको फेवर करेगी. और रिवर्स बायसिंग ऑलरेडी है, तो क्या होगा, तो ये ओपन सर्किट रहेगा, तो ये जो वोल्टेज जैसी भी है वो वहाँ पे आउटपुट में अपीयर हो जाएगी. ओके, ये प्रोसेस चलता रहेगा जब तक कि यहाँ पे वोल्टेज, जब यहाँ पे क्या होता है कि ये ज़्यादा नेगेटिव हो जाती है, वीबी से ज़्यादा क्रॉस कर जाती है, वीबी से और ज़्यादा नेगेटिव हो जाती है. कहाँ पे, यहाँ पे इस एंड पे. और इस एंड पे जब ये ज़्यादा नेगेटिव होती है तो वो डायोड को ना, क्योंकि वीबी से ज़्यादा नेगेटिव हो गई, वीबी ने रिवर्स बायस कर रखा था, पर इस वोल्टेज ने क्या किया, डायोड को फॉरवर्ड बायस कर दिया. तो शॉर्ट सर्किट हो जाएगा, तो आउटपुट में क्या होगा, वीबी अपीयर हो जाएगी. तो ये आउटपुट में ऐसे, ये वीबी आउटपुट में ऐसे रहेगी. फिर जब ये नेगेटिव वोल्टेज कम होगी तो ये वोल्टेज फिर इसको रिवर्स बायस कर देगी. ठीक है, रिवर्स बायस करेगी तो जैसा भी सिग्नल है वो वैसे का वैसा वहाँ पे आ जाएगा, क्योंकि रिवर्स बायसिंग में क्या होता है, ये शॉर्ट ओपन सर्किट हो जाता है ना. ओपन सर्किट में जो वोल्टेज यहाँ पे होगी वो यहाँ आ जाएगी. सो वैसी वोल्टेज यहाँ चलती रहेगी. फिर नेगेटिव आएगा और ज़्यादा नेगेटिव हो जाएगा तो फॉरवर्ड बायसिंग हो जाएगी, तो ये फिर वीबी बन जाएगा. अच्छा, एक बात का ध्यान रखना है, हम डायोड को आइडियल कह रहे थे, पर डायोड यदि हम आइडियल नहीं कहेंगे, प्रैक्टिकल डायोड होगा, जैसे सिलिकॉन का बना हुआ डायोड. तो सिलिकॉन में जब डायोड ऑन होता है तो उसकी भी वोल्टेज होती है कितनी, 0.7 वोल्ट. ठीक है, तो अब जो हम रेफरेंस लेवल कह रहे हैं ना, वीपी बोलते हैं ना, जैसे वही वीपी से क्लिपिंग होती है. अब वीपी से क्लिपिंग नहीं होगी. जैसे ये है, ये बैटरी नेगेटिव पॉजिटिव है और ये डायोड पे वोल्टेज बनी है, डायोड के क्रॉस डायोड वोल्टेज, ये पॉजिटिव नेगेटिव ऐसे है. तो नेगेटिव पॉजिटिव ये दोनों ऐड हो जाएंगे. दोनों ऐड होके कितना बनेगा, रेफरेंस लेवल वीपी प्लस वी ऑन. और यदि ये वाली बैटरी उल्टा हुई वी ऑन से, ठीक है, जैसे पॉजिटिव नेगेटिव वी ऑन का है और ये माइनस प्लस हो गया, माइनस ऊपर प्लस नीचे, तो फिर माइनस में फिर सब्ट्रैक्शन होगी, फिर रेफरेंस लेवल बनेगा वीपी माइनस वी ऑन. यदि हम प्रैक्टिकल डायोड लेंगे तो प्रैक्टिकल डायोड में फॉरवर्ड रेजिस्टेंस भी कुछ ना कुछ उसकी वैल्यू रहती है, बेशक बहुत कम. तो ये थोड़ा सा डिस्टॉर्शन भी देता है फॉरवर्ड रेजिस्टेंस क्लिपिंग के केस में. तो ये प्रैक्टिकल डायोड की कुछ लिमिटेशंस है कि रेफरेंस लेवल थोड़ा चेंज हो जाता है, एग्जैक्टली वी भी नहीं होता, वी एन उसमें ऐड भी हो सकता है, सब्ट्रैक्ट भी हो सकता है, डिपेंडिंग अपॉन इन दोनों में क्या संबंध है, पोलैरिटी में क्या है, कैसे है. सो आई एम टॉकिंग here this is, if this is a rear diode, it is having some voltage across the rear diode, which is V on. Okay, and there's another VP. The reference level now will change if we are considering a practical diode. Now the reference level will be VB plus minus V on, depending upon the polarity of the both. Like particularly this case, it is VB plus V on. But in another case, it may be VP minus V on. If here it is negative positive, but here it is, if it is positive is here and negative is above, then it may be VB minus V on. So practical diode, like silicon having 0.7 volts, so that 0.7 may be added or subtracted in VB, and then the reference level will be slightly changed. And practical diode also having some forward resistance, so which makes some distortion in the clipping and the output clipping signal. Okay. Now this again the ideal diode and double clipper circuit. So there are two lines here, battery positive negative, here negative positive, and this battery making this diode, this diode reverse bias, because positive is here and negative, and this is negative, this is positive. This battery making this diode reverse biased. So both the diode are reverse biased with VP and VP1 and VP2. So when the signal comes, okay, and the signal strength is less positive, and there will be no effect on this diode, because the positive going signal is coming. This diode is already reverse biased, so it again favors the reverse biasing for this diode D2. But this positive going coming, this diode this voltage tries to make the D1 forward biased. But this, even when the strength is low, signal strength is low, then because of this voltage, this is at the reverse biased. So whatever this voltage, it appears at here, this end, because this circuit is broken, this circuit is broken. But when the input signal just crosses this end, this part of the signal, it makes the diode D1 forward biased. This voltage VP1 appears across the output because this is short circuit. So voltage across output will be VP1, and if it is a practical diode, it will be VP1 plus V on. Okay, now when the signal goes down, again this positive part of the signal is not able to make it forward biased because this strength is less than VP1. So again the diode becomes reverse biased. Broken circuit, voltage at here reaches to this end. So that's why output is like this. Now when the negative part comes, negative part it doesn't have any, negative cycle does not have any role. This negative end could not make D1 forward bias. Okay, because VB1 already the D1 is reverse biased. So this negative half could not make it forward biased because it's the opposite. But this negative tries to make this D2 forward biased, and when voltage crosses this end, this strength of the signal is greater than VP2. This diode becomes, so when the negative signal crosses this end, it makes the D2 forward biased. When D2 forward biased short circuit, so voltage between the two ends, now that becomes VP2. So this voltage is VP2, and if it is a real diode, VP2 plus V on. The voltage remains VP2, again the signal strength becomes weaker, and this voltage makes again it reverse bias, open circuit. Open circuit means whatever the voltage set here reaches to this end. So the same voltage appears again. So this process repeats. Okay. Thank you. This is what the clipping is.